What's going on, guys? It's the Unhinged Engineer here, back with episode 16 of my Georgia Tech grad school vlog. So this is your first episode with us, welcome. Today is actually the first real episode of my second class, which is on AI for video games. I don't know if it's video game AI or game AI. It has like 8 different names, but it's about AI for video games. I took it this summer just kind of as like an easier class, but also one that still had interesting material, and thus far that's proven to be the case. So even though we're early on, I'm pretty optimistic about the class. I'm excited, and I'm excited to share what I've been up to with you for the last, I guess, week and a half-ish. So like I said, I made a video already talking about why I chose the class, what it's about in broad strokes, like the syllabus and the assignment structure and all that stuff. I made one of those before going on vacation for a little bit, and then just recently, like a couple days ago, I posted my formal review of the previous class I took, which was AI Techniques for Robotics. So lots of action going on with the blog, and today we're finally back to normal, just kind of going through the class as we have been doing for the last however many episodes, 14, 15 episodes. And so let's talk about what that's been like. So I actually missed the first week of this class, which didn't seem too bad, like as was the case with AI Techniques for Robotics. Like the lectures are asynchronous and all that other stuff. There wasn't anything due that week. There was a kind of tutorial assignment that got you set up with Unity. So as you may have seen in the last vlog, we're doing most of our development in Unity with C#. So Unity is like the game engine that we're simulating everything inside of. And then C# is the scripting we're doing to implement the different AI algorithms we're learning about, right? And so there was an optional assignment to set up Unity and kind of make sure you have everything working. I did not do that assignment. And so for this 1 week that I had to do the first assignment, I also had to get set up and everything. And as I'll mention when I get to the assignment itself, the Unity workflow is definitely interesting to me, but I feel like learning how that works is going to be a useful skill in and of itself. So yeah, so I came back from vacation a week late into the course, and so I had about 4 or 5 days, if you include the couple I was basically useless from jet lag, to do this assignment. And what this assignment was about was it was called the grid lattice. So in general, in video game environments, we have like continuous movements. You can be at any position in 2 or 3D space, depending on how your video game is set up. But for like AI agents, like the bots we might shoot at in a first-person shooter, it would be a lot to give them continuous movement, like the ability to occupy any space. And so what we do is we discretize that space into a set of like coordinates, grid cells, whatever you want to call it, nodes in a network, and we allow the agent to move between those, right? And this is actually a concept I'm really familiar with aerospace engineering, where again, like if we're trying to do some kind of path planning, it's really hard to kind of perfectly lay out a continuous B-spline. A lot of times we chunk it up into a set of waypoints. And so that's kind of what we were tasked with doing for this assignment. We were given a Unity environment. We had to chop it up into grid cells, and then, in such a way that an agent could move around with it. I think we're going to start to do more interesting stuff with that grid next week, but yeah, that's what I was up to for this one. And so before getting into that assignment itself, I watched through all the lectures. Basically, those lectures were kind of separated into 4 bins. One was kind of basic terminology, like basic AI movement, video game terminology, stuff like that. It's nothing fancy. Number 2 was about like more AI on a budget, right? So when we're running a video game, we're usually stressing the crap out of our computer. And so it's important that we write compute effective algorithms. So there's lots of talk about converting between floating point integer, overflow errors, like pretty interesting stuff. Very, very like classical computer science things. Speaking of computer science, there was also a large emphasis on computational geometry, which I think is pretty cool. According to the lectures, that'll be more relevant in the first half, because that's kind of when we're talking more about movement systems. And then in the second half, we're going to shift more towards what you may think of as AI traditionally, where it's like decision trees and more about the decision-making process rather than how our agent's going to navigate an environment to do certain things, right? So computational geometry seems to be an important concept for the first half of this class, and that was reflected in the lectures I had to watch. And then the last one was about Unity setup, and they were actually really good. It just kind of showed you like how to set up the engine, what your workflow is like for the homework assignments, and basically they give you this big repo that we're doing everything in, kind of similar to my last class. And just, it put me in a good position to kind of get right to the assignment. So I didn't really get affected by missing that first week too badly, other than a little bit of natural anxiety, right? But once I'd gone through all of those lectures, that was the point at which I started doing the homework assignment. So like I said, it was about the grid lattice. And so we were given these Unity environments, and we had to chunk it up into a grid that an AI agent could maneuver itself within, right? And so the idea here is kind of like we're separating our environment into a grid, but our obstacles don't always fit nicely into grid cells, right? So maybe they're at an angle, or they're at this weird size, or like some of them are rectangles, some of them are stars or circles. And so all of our obstacles don't really fit neatly into our grid. And so we need to know which squares to mark as untraversable. So traversable meaning open, or untraversable meaning occupied by an obstacle, right? And so this is not in any way like a perfect science, nor was it intended to be for this assignment. Like, this is an imperfect approximation. That's kind of the whole point. We're doing this to save compute and be able to run more efficient algorithms. And so that was more of what this assignment was about. So half of it was just kind of like taking in the dimensions of your environment and plotting things accordingly, which was actually more difficult than I realized because you don't really know where your grid should start and end relative to the origin. Furthermore, you don't really know how big or small this grid is going to be ahead of time. Like, all the test cases vary pretty significantly. And that was a little frustrating, but I actually completely see why he set it up that way. I think that makes a lot of sense. On that note, brief tangent, I do think that he's putting a really strong emphasis on good like software engineering and software development practices. So that's kind of what I was getting at, where you don't really know what specifications the user is going to need on the other end. And so you need something that's actually robust and extensible in that way. I think that's interesting. I don't like that we only have a limited number of submissions, because that's supposed to simulate like you want to give finished code to your stakeholder, I guess, your customer or whatever. I understand what he's getting at with that, but it also just caused a lot of anxiety to like only have one or two, usually it's two, submissions to Gradescope, especially if like you're taking averages of those different submissions. I liked in AI Techniques for Robotics, I could just kind of hurl stuff at the auto grader until I got a grade I wanted. That was nice. But I don't have that luxury anymore. It's okay. It is what it is. So yeah, that was kind of the first half of the assignment, was plotting out that grid. And then the second half was looking at these obstacles, which were defined as polygons. We were given a set of vertices that kind of defines a shape with an arbitrary amount of sides. So given those vertices, how do you chart out what's traversable versus untraversable on that grid? And so there were ones where like an edge would go through a grid cell, or there would just be a point, like a corner in that grid cell, or one is completely enclosed by the obstacle, someone kind of like in the center of it. And so there are lots of different ways you could tackle this problem. I didn't really use the one provided in lectures. I hope that goes over smoothly. I took a pretty different approach. So in the lectures, we were mostly taught about, given a polygon of an arbitrary size and edges, like lines of an arbitrary size, different ways to check intersections. I took a different approach where I kind of just chopped up those edges into like waypoints and then tested each individual point. Because my logic was, it saves you a lot more compute to just check if a point is in a polygon, right? So you just kind of have like a range of X, Y values that defines that grid cell. Because an important clarification, I shouldn't say polygons. I'm checking if the points are within squares. That's the key point, right? So since the grid cells are all squares, it's easy to just say, does this point fall within the range on the x-axis and the range on the y-axis? If it falls in both those ranges, then I can mark it as within that grid cell, right? That was much easier to me versus like looking at each edge of the grid cell and, doing this like weird cross product thing with the edges of each polygon. It just seemed like a pain in the ass, to be quite frank with you. And so I just took the other approach where I interpolate the edges into different points. So we'll see how that goes. I think it should go over okay. But, it wasn't anything completely crazy out of the ordinary. I used like one super basic Unity package helper function and I cited it. So hopefully that goes over well, but if it doesn't, then you'll hear about it in a future video. So Yeah, so working in Unity was fine. It took a little bit to kind of get over the hump, but once I did, it was smooth sailing, right? And C# also seems pretty easy to pick up if you've written C or C++ before, which I have extensively. So yeah, so far so good. We will see how that progresses, but yeah, that's basically what I've been up to for the first week. It's been a really interesting class so far. I'm super excited. And yeah, I think next week's assignment is about a path network. So I think now we're kind of getting more into pathfinding and moving in this environment, whereas this first assignment was just kind of like setting up a discretized environment that you could move within. So it's going to get a little bit more interesting here shortly, but overall I think it's been a good introduction to the class. I'm excited about it. I'm excited to get to know the instructors in the office hours better, the instructors and the TAs better. I haven't really interacted with anybody yet. I've kind of been flying solo, so yeah, lots of exciting stuff to come. Thank you so much for watching, and I will see you in the next vlog episode.